Okay. So next concept which we are studying is Ohm's law. What is Ohm's law? Let us see. See here, consider this is a resistor which is connected in a circuit. Okay, ma? Resistance is R, potential difference is V. Okay, ma? Then how much current will flow in this circuit? That amount of current flowing in the circuit is directly proportional to potential difference applied. This law is called as Ohm's law. అర్థమవుతుంది కదమ్మా? So if you are applying less potential difference, current flowing also will be lesser. You apply more potential difference, battery capacity ఎక్కువ ఉందనుకోండి, automatically more current will flow in the circuit. So therefore I is directly proportional to V. This is called as Ohm's law. Okay, ma? And if I want to write a proportionality constant, I can write V is equals to R into I. Okay, ma? And what is meant by this R? R is called as resistance of circuit. In the circuit, what is the total amount of resistance present? That is called as R. Okay? Are you able to understand, ma? So therefore, how can I calculate R value? R is equals to V by I. Okay? Is it clear? So therefore, how much potential you have to apply for 1 ampere of current to be produced? That is called as resistance. Are you able to understand? So for same amount of current produced, for same amount of current produced, okay, I can write R is directly proportional to V. Can I write like this, ma? So I want the current to be same. So if I increase the potential difference, what I have to increase? I have to increase resistance automatically. Huh? And what is meant by resistance? Resistance is nothing but opposition to the flow of current. Opposition to the flow of current. Okay, ma? Conductors have less resistance. Okay, ma? Conductors have lesser resistance, whereas insulators have very huge amount of resistance, and semiconductors are in between conductors and insulators. Materials we can divide into 3 types, no? Metals, metalloids, non-metals. Non-metals are nothing but insulators. So insulators have high resistance, metals have low resistance. So metals doesn't oppose the current very highly. They also will oppose, but opposition is very less. For example, in these wires you can find copper, no? Why we are using copper only? Copper doesn't oppose the flow of current to a large extent. It also opposes, but very less. Okay? Okay? Sima. So, if I want to draw a graph between voltage and current, then this is the type of graph which you will get. What is the meaning of this one? It means that, Sima, if voltage increases, current also increases. That is the meaning of this graph, no? Clear, no? If the potential difference increases, what happens to current? Current flowing in the circuit also will increase. And a graph will be a straight line. For which type of conductors? For ohmic conductors. Ohmic conductors means what? The conductors which follow Ohm's law is called as ohmic conductor. Understood, Amma? So write down that also. So, conductors following Ohm's law. Conductors following Ohm's law. They are called what? They are called as ohmic conductors. Okay? But for semiconductors, the graph may be different. For semiconductors, you will get a completely different kind of graph. But this is for only metallic conductors. Okay? Okay, SIMA. So resistance of circuit we are studying. What is meant by resistance? Opposition to the flow of current is called as resistance. This is the symbol of resistance. Unit is ohms. Ohms is the unit of resistance in which system? SI system. Okay, and this is how we represent a circuit. And resistance of any conductor, it depends on two factors: length of conductor and area of cross section of conductor. So what is the first statement I will write? Resistance is directly proportional to length of conductor. If length of a conductor increases, resistance also increases. Why? What is the reason? అదే ఎందుకు అని అడుగుతా ఉన్నా. So this electron, it should travel greater distance, no? So number of collisions will increase. So you have to apply more work, you have to do more work. The EMF of the battery should be greater. So if length increases, resistance automatically increases. Similarly, resistance is inversely proportional to area of cross section. That is, if area of cross section increases, thickness increases, then resistance automatically reduces. What can be the reason of this one? If cross section increases, electrons will find more ways to travel, no? So automatically resistance reduces. Okay, so if I combine both of them, I can write R is proportional to L by A. Okay, ma? And if I want to write a proportionality constant, R is equals to rho L by A. And what is called this rho? Rho is called as resistivity of the conductor. Resistivity of conductor. Are you able to understand, ma? Rho is a constant of proportionality, ma. And that constant of proportionality is rho, which is called as resistivity. So how can I define resistivity? Resistivity can be defined like this. So R is equals to rho L by A, no? So therefore I can write rho is equals to AR divided by L. This is resistivity, no? So how can I define this resistivity? Resistance per area AR by L. And per length of conductor. Okay, ma? This is called as resistivity. So resistance is a general property, ma. Resistance is how effectively a particular metal is able to obstruct the electrons. That is called as resistance. But resistivity is a specific term. Resistance per area per length. For this much of area and this much of length, what is the resistance present? This is called as resistivity. It means that resistance does not depend on physical dimensions, but resistivity depends on physical dimensions. This is one important point which you should understand. Are you able to understand? So what is the note point here? We have to write, note point is that resistance is property of material. Property of material. It does not depend on, it does not depend on what you called resistance is a property of a material, ma? It depends. Does not depend is not correct. It depends. Resistance depend అవుతుంది. ఒకసారి ఉండండి, మళ్ళీ ఆలోచిద్దాం. ఓకేమా? So it depends on dimensions of material. Okay, ma? But resistivity does not change on dimensions. But resistivity does not depend on dimensions. Are you able to understand, ma? Because resistivity is always defined per unit area per length, no, ma? For this much area and this much length, what is the resistivity? That is always a constant. But resistance, as the length increases, resistance increases. As the area of cross section increases, resistance decreases. So resistance depends on dimensions. That's it. Okay? Right now. Unit of resistivity also we will see, ma. Unit of resistivity. Okay? So resistivity is written as AR divided by L, no? Clear, no, ma? Area means length into length, R divided by L. L get cancelled. So unit will be how much? Ohm meter. Ohm meter is the unit of resistivity. Resistance is measured in ohms, no? Length is measured in meters. So ohm meter is the unit of resistivity. Ohms is the unit of resistance. Okay? Remember, up to here we will continue. Okay. So Sima, this is a very important relation. Relation between current density and electric field. J is current density only, no? E is electric field. So first of all, I will write one equation of J in terms of relaxation constant. Okay, or relaxation time. What is meant by relaxation time? Do you remember? Chapandi. Relaxation time means time taken between two collisions is called as relaxation time. So I want to write J in terms of relaxation time. How can I write? Sima. Okay. We have this relation, no? I is equals to NEA VD. So I by A will become J, no? So this is one equation of J. NEVD is another equation. Okay, ma? Yesterday we have written one equation, no? J is equals to I by A. The amount of current flowing through unit cross-sectional area is called as J. This is second formula, NEVD. Clear, no? Now, yesterday we derived this relation, no, ma? Relation of drift velocity. E tau divided by M. So take this drift velocity and substitute in this equation. I will get one more equation for a J, current density. Are you able to understand? So how many equations we have derived? First equation, second equation, and this is the third equation. Are you able to understand? Similarly, according to Ohm's law, we know this relation, no? I is equals to V by R. Okay, ma? And what is meant by R here? R is nothing but R is nothing but rho L by A, no, ma? So A, if it goes to the numerator, and if you take to this side, it will become I by A. So I by A is again a J. And what is the remaining value here? V by rho into L. What is rho? Rho is resistivity, no? Rho is what, ma? Resistivity. And what is the reciprocal of resistivity? It is called as conductivity. Okay? And it is represented by the symbol sigma. Understood, no? 1 by rho is called as resistivity, and that is called as 1 by rho is called conductivity, represented by the symbol sigma. Understood, no? So therefore, V by sigma into L. And V, what is V by L? V by L is nothing but electric field, no? So this is the relation. J is equals to sigma into E is the relation between current density and electric field. Okay? Right now. Okay. Sima. See this question. So estimate the average drift speed of conduction electrons. So he is asking us to find out the drift speed. What is the cross-sectional area? Cross-sectional area is 1 into 10 power minus 7 meters square. And it is carrying how much current? It is carrying a current of 1.5 ampere. Okay. Then he said that one copper atom contributes 1 electron. Are you able to understand? One copper atom will give 1 electron. And density also he gave. Density is how much? Density of copper is 9,000. So 9 into 10 power 3 kg per meter cube. And atomic mass, molecular mass also he gave 63.5 atomic mass units. Okay, no? So he is asking us to find out drift speed. So where I can find drift speed? There are many formulae. No? One formula is drift speed is equals to E tau divided by m. This is one formula. Yesterday we derived this one. No? But this equation, is it suitable here or not? Try to say. Charge of electron we know, but electric field not given. Relaxation time not given. So we cannot use this relation. Okay. Any other equation? So I is equals to NEAVD. This equation also we have, no? Okay, ma? Now in this equation, current is there. Current is given, no? Charge of electron is there. Area of cross section is also there. N value is not given. N. What is N? Number of electrons per unit volume, that is not given. So just if I can find out this N value and substitute in this equation, I can get the answer. Okay. N value, how can I calculate? Let us see. What is N here? Number density, no? Number density. What is meant by number density? Number of electrons. Okay, ma? Per unit volume. This is called as number density of electrons. Are you able to understand? Volume, is it given? Volume also it is not given, no? So, but density is given, no? Density is given and mass also given. And this is the mass of what? This is the mass of 1 mole. 1 mole of copper, no? 63.5. U means atomic mass units, unified mass. Are you able to understand? So therefore, we know that density is equals to mass by volume. So therefore, volume can be written as mass by density. Okay. So let us consider mass to be 1 atomic mass unit only. Okay. How much mass I am taking? I am taking mass as 63.5 atomic mass units divided by density. Density is how much? Density is 9 into 10 power 3 kg per meter cube. Are you able to understand? So mass 63.5 U means what do you understand? Mass he gave in terms of 63.5 U, no ma? U means what? Unified mass, or just you can say 63.5 grams of copper will make 1 molar mass. That's the meaning of this one, no? One single copper atom will have this much mass. Single copper atom will have 63.5 atomic mass units. But if you take 1 mole of copper, 1 mole of copper, it converts into unified mass, converts into grams, no? కెమిస్ట్రీలో చదవలేదా మీరు? చదివినారు కదా. దరిద్రం ఏమంటే నేనే ఇది కూడా చెప్పింది. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో 63.5 U means atomic mass units. That is the mass of one single atom. But if I want for 1 mole of atoms, then U converts into G, grams. 63.5 grams. Okay, ma? So 63.5 grams, no? 1 gram is equals to how much? 10 power minus 3 kg. Now it has converted into kgs, no? Are you able to understand, ma? So therefore, volume I have calculated. Now just substitute in this equation. So therefore, number density N is equals to. Now can you say how many number of electrons will be there, ma? Unit of volume I have calculated. Volume I have calculated, no? Huh? Now number of electrons will be how many? Chappan. Number of electrons will be how many? ఇది కూడా చెప్పలేకపోతే కష్టం రా. Why you have to take Avogadro number? I am asking number of electrons are how many? How many number of electrons will be there? Mass, how much I have taken, ma? I have taken 1 molar mass, no? 1 molar mass of copper I have taken, no? 1 mole of copper will contain how many molecules? Avogadro number 6.023 into 10 power 23. And each atom will contribute how many electrons? చదవండియా, 1 copper atom contributes 1 electron. So therefore, number of atoms and number of electrons, they are equal, no? Are you able to understand? Because I have taken mass to be 1 mole, number of electrons should be equal to number of atoms, which is again equal to Avogadro number. Are you able to understand? So substitute. So therefore, if I substitute in this equation, number of electrons are how many? 6.023 into 10 power 23. Divided by volume. Volume how much? 63.5 multiplied by 10 power minus 3. This is denominator in denominator, it becomes numerator. 9 into 10 power 3. So just do this calculation. You will get number density of electrons. Are you able to understand? Once I get number density, very easily I can calculate the drift velocity. Is it clear? Come on, make a note up to here. Okay, so what is the note point here? I have to write. Note point is that as we have taken 1 molar mass, number of atoms will be how many? 6.023 into 10 power 23. Therefore, number of electrons also same. Number of electrons also will be 6.023 into 10 power 23 itself. That's it. Is it clear? Are you able to understand how we are doing? Now once you calculate that value, now you substitute all that value in this equation and you calculate the drift velocity. Okay? So, where shall I calculate? I will calculate here. Okay, ma? So, therefore, I is equals to NEA VD. Therefore, VD is equals to I by NEA. Current is how much? 1.5 divided by number density. Number density is this much, no? So 6.023 into 10 power 23 multiplied by 9 into 10 power 3, and this goes to the numerator, multiplied by 63.5 multiplied by 10 power minus 3. Okay, ma? E means a charge of electron, no? 1.6 into 10 power minus 19 multiplied by area of cross section. Area of cross section is 1 into 10 power minus 7. So just to do this calculation, you will get the drift velocity. Okay? And the answer is 1 by 160 meters per second. Okay, ma? That is the drift velocity of this particular electron in this metal. Okay? That's it. See, ma. So second question what he is asking is, compare drift speed with the thermal speed of copper atoms at ordinary temperature. So consider a single copper atom. Okay, ma? If it is a single copper atom, then how much speed it will have, ma? That speed I can call it as RMS speed, no? RMS speed is equals to square root of 3 kT divided by m. Do you remember this formula? Okay, ma? RMS speed when atoms are present in gaseous form. So he is asking us to take only single copper atom. So I am taking equation for only small m. What is meant by small m? Mass of single copper atom. That is called m, no, here. What is meant by K? Boltzmann constant 1.38 into 10 power minus 23. And temperature, which temperature he is asking us to calculate? Any ordinary temperature. So let us consider T is equal to 27 plus 273, which is equal to 300 Kelvin. Okay, ma? So ordinary temperature means I am taking 27. You can take 30, 33, anything. Okay. So now substitute this value. So Vrms is equals to square root of 3 into K value 1.38 into 10 power minus 23 multiplied by temperature 300 divided by mass. What is the mass of single copper atom? 63.5 atomic mass units. Okay, ma? One atomic mass unit is how much? 1.66 into 10 power minus 27 kg. Do you remember? Huh? One atomic mass unit mass will be how much, ma? 1 AMU is equals to 1.66 into 10 power minus 27 kg. Clear, no? This value always you should remember. So from here you will get one velocity. Let us see what is the velocity we will get. 1.1 1 minute. It is 342.57. 342.57 meters per second. So copper atom will have this much speed. Okay, ma? In which temperature? At a temperature of 27 degrees Celsius or 300 Kelvin. Okay. Now he is asking us to compare. No, what is meant by comparison? Comparison means what? Comparisons means ratio, that's it, division. Okay, ma? So drift speed of copper or drift speed of electron of copper divided by RMS speed. Okay, or we will do one thing, ma? We will take Vrms by Vd, that is better because this is a bigger value, no? So Vrms of copper divided by drift speed of electron. Okay, Vrms of copper is how much? 342.57 and the drift speed of electron 1 by 160 meters per second, no? So just do this calculation, that is the comparison. Are you able to understand? He has taken in opposite sense. Okay. Do this calculation, you will get the answer. Okay. Okay. See, ma. So this is the question. So when a potential difference of 1.5 volts is applied across a wire of length 0.2 meter and area of cross section 0.30 mm square, a current of 2.4 amperes flows through the wire. Number density n value is given, then calculate the average relaxation time. Okay, ma? So potential difference is given, area of cross section, length, current. By looking at all these equations, parameters, I can write I is equals to NEA Vd. This relation I can write, no, ma? But here I don't have any relaxation time. But I know drift velocity equation, no? Drift velocity is equals to E tau divided by m. This relation we know, no? So take this and substitute in this equation. Okay? So therefore I is equals to NEA multiplied by E tau divided by m. So I is equals to N E square A E tau divided by m. Okay? Now all the values are given, no? Current, is it given? Current is given. Number density is given. Charge of electron we know. Area of cross section is also given. Electric field. Electric field is not given, no? How can I calculate electric field? V by D or V by L, no? Huh? What is the potential difference applied? 1.5. What is the length of the wire? 0.22. So you calculate this one, you will get electric field also. Okay. Next, what he is asking us to find out? He is asking us to find out relaxation time. And what is meant by mass? Mass of electron, no? Mass of electron is 9.1 into 10 power minus 31 kg. That's all. So just to substitute all these values, you will get a tau value, and that is my answer. And area of cross section, be careful, here it is mentioned in millimeter square. You have to convert it into meter square. So 0.30 multiplied by 1 millimeter is how much? 10 power minus 3. Whole square is there, no? So I will write whole square also. Okay? Now substitute all these values, calculate a tau value. That is my answer. Okay? So answer which you should get is 4.51 into 10 power minus 16. 4.51 into 10 power minus 16 seconds. Seconds are milliseconds. Seconds. That is our answer.